Now, the other element in the pathogenesis is going to be on the GI tract, and it's going to be diaphragmatic hernia. When you have a diaphragmatic hernia, it can be also an etiology of an acute or a birth asphyxia. Is it clear? So those are the different elements that you have to put as etiologies of birth asphyxia based on the fetal abnormality. Now, after visualizing the etiology of the birth asphyxia, we have to now go to the next one, which is the pathophysiology of birth asphyxia. Is it clear? Pathophysiology of birth asphyxia. Now, the pathophysiology of birth asphyxia is going to be the similar pathophysiology of prematurity, which is going to be the similar pathophysiology of low birth weight. Is it clear? So I'm not going to speak about those different pathophysiology again, and they are going to be similar, and they are also the ones which are going to be more common in the cases of birth asphyxia. The pathophysiology are going to be more common in the cases of prematurity, and pathophysiology are more common in the cases of low birth weight. Is it clear? So those are, but generally all of them have the same pathophysiology. The pathophysiology generally of birth asphyxia, prematurity, low birth weight is going to be associated with one, you're going to have hypoxia. So you have the pathophysiology related to hypoxia, and you have two, the pathophysiology related to hyperoxia. Is it clear? Hypoxia is when you have a saturation less than 90%, and hyperoxia is when you have a saturation less than 95%. So every time that you have a child with birth asphyxia, prematurity, or low birth weight, saturation should be tried to be maintained between 90 to 95%. That's the general target. Is it clear? Now, inside hypoxia, you need to know that you're going to have ischemic disorders that was visualized under the compensatory ischemic mechanism, and you have also acidotic disorders that was visualized under the anaerobic mechanism of compensation. Is it clear? In hyperoxia, there's only hyperoxia. Now, you need to know that what under the ischemic mechanism, we have many different diseases that can be associated with them. The first one, we have to start from the central nervous system. In the central nervous system, you are going to have hypoxic ischemic encephalopathy that can later on result in life when you're going to have a developmental issue to a cerebral palsy. Never speak of cerebral palsy when you have a neonate. Is it clear? You only speak of cerebral palsy when there is already a developmental issue, because cerebral palsy is defined as an irreversible, it's an irreversible progressive. Is it clear? It's an irreversible progressive neurological damage. Is it clear? Irreversible progressive neurological damage from hypoxia in the early lives. So this irreversible tells you that it can never change again. That is, there is no complete definitive management for cerebral palsy. And progressive means that it is going to be revealed as the child grows in age. Is it clear? In the developmental issue by using the Denver score. Is it clear? You use the Denver score in the developmental issue. Is it clear? So that is in cerebral palsy. So now you need to know that what irreversible progressive neurological damage from the hypoxia in early lives, that is cerebral palsy. And you need to know that what this cerebral palsy has four main divisions. It is divided into spastic. Spastic is when they have involvement of the pyramidal tracts. Is it clear? It is like a pyramidal syndrome in neonates. So that's a case of a spastic cerebral palsy, meaning that there's going to be hypertonia, hyperreflexia, and all those other signs like in the pyramidal syndrome. Now, the next one is ataxic. Ataxic now is in the case of a cerebellar syndrome in adults, just like a cerebellar syndrome for neonates. Is it clear? When you have an ataxic cerebral palsy, it's just like a cerebellar syndrome in neonates, meaning that they are going to have all the signs of cerebral syndrome, like tremors, like ataxia. So those terms that I've explained in cerebellar syndrome that you can visualize in the stroke tutorial. Is it clear? So now the next one is cerebral. The next cerebral palsy is going to be dyskinetic. Dyskinetic is going to occur in pathologies of extrapyramidal tracts. So just like the extrapyramidal syndrome involving Parkinsonism. Is it clear? So you have element of dyskinetic. So if you have Parkinsonism, you have chorea, you have athetoid. Is it clear? Chorea, you have athetoid, you have balismus, you have Parkinsonism. All those are located in dyskinetic, but in children in particular, you have chorea and you have athetoid. Is it clear? In dyskinetic. And then the last cerebral palsy type is going to be mixed type. So those are the different cerebral palsy that you're going to have. Is it clear? Now, after visualizing the hypoxic ischemic encephalopathy, the next and cerebral palsy is going to be late complication. Next, after hypoxic ischemic encephalopathy, you're going to have periventricular hemorrhage. Periventricular hemorrhage. Now, the simple answer to why is there's a periventricular leukomalacia, periventricular leukomalacia, and there's going to be ventricular hemorrhage. Is it ventricular hemorrhage? So every time that the child is twitching, never go and do a lumbar puncture without doing a CT scan, because there may be signs of raised intracranial pressure with shift at the level of the brain when you do CT scan, and that CT scan may aggravate that lumbar puncture may aggravate the compression inside the brain by resulting to herniations. Is it clear? By peculiarly is going to result to coning or tonsillar herniation that may kill the child with a direct respiratory arrest because of the compression of the brain stem. So you can have ventricular hemorrhage, and this ventricular hemorrhage occurs because of ischemia inside the periventricular arteries. Is it clear? When you have ischemia inside the periventricular arteries, it's going to result to necrosis, and the blood is going to be released at the level of the ventricles. Is it clear? So that's the ventricular hemorrhage. So all those are the ischemic complications at the central nervous system. Now the next one, we're going to visualize ischemic complication inside. After the ischemic complication central nervous system, you're going to have ischemic complication inside the cardiovascular system. In the cardiovascular system, you're going to have a apnea bradycardia. Is it clear? So you have a bradycardia, apnea or bradypnea syndrome. Is it clear? So that's the first element you're going to have in cardiovascular system. Also, you need to know that when you have ischemia, there's a problem of oxygenation of blood. Since there is a problem of, when you have hypoxia, there's a problem of oxygenation of blood. And since there's a problem of oxygenation of blood, the ductus arteriosus is not going to close. Is it clear? That's why you're going to have a patent ductus arteriosus. Patent ductus arteriosus